Ready?
All right. Thank you for joining our event on smartphone contact tracing for coronavirus and privacy, and a privacy-first approach from MIT. Joining us today is Ramesh Raskar. Ramesh is an associate professor at the MIT Media Lab, and he directs a camera culture research group over there. Ramesh's focus has been on AI and imaging for health and sustainability. And his research spans both the physical world, the digital world, and then combining that with a privacy-aware machine learning in a global context. Ramesh has received numerous awards, including the Lemelson Award, the ACM SIGGRAPH Achievement Award, the DARPA Young Faculty Award, the Alfred Breed Sloan Research Fellowship, the TR 100 Award, and the list goes on. He has worked outside of MIT on special research projects at Google and Facebook, and he's co-founded and advised several companies, and he's a good friend and a big supporter of the MIT Club of Northern California. So thank you, Ramesh, for joining and sharing your thoughts on this very valuable topic. Before we get started, I just wanted to let all the attendees know that we'll probably spend about 20 to 30 minutes in a talk and then open it up for question and answers. Please put your questions in Slido, and I just put in the link for Slido in the chat window. Please use that to ask your questions. And the good thing is you can upvote and downvote each other's questions, and we'll take it from there. So with that, Ramesh, over to you.
Fantastic. Let me share my screen. I need to share my screen. Excellent. And hello, everyone, and wonderful to be here with you. I know it's kind of gloom and doom when it comes to the health, public health of our loved ones, and also the economy. But let's talk about, is this a time to start thinking about building resilient societies? And this epidemic may be our opportunity to rethink not only how we're going to overcome public health issues, not only how we're going to restart the economy, but how we're going to build resilient societies. And this is work with about 60 to 70 other people that we have launched called SafePaths. So this is a platform that's being built, COVID SafePaths, with many leading organizations across the world, many big tech companies, of course, MIT and Harvard and Mayo and so on. So it's just been a fantastic, fantastic partnership. So traditional contact tracing is about backtracing who might have come in contact with an infected person. So the case of patient 31 in Korea is an interesting one. This is a lady who went to the hospital because she had a car accident. And after that, she ended up going to church, and she ended up going to lunch with others. Sorry. And in the process, came in contact with more than 1,000 people. And so the authorities had to interview more than 1,000 people to see who might have come in contact with her and are they getting sick. And this involves kind of talking to people at this restaurant, talking to those people in those churches and so on. And as you can imagine, that's very invasive in terms of privacy. And it can only be done with a lot of manpower. So this back tracing is traditionally the form of contact tracing. And if you start to do this automatically using some digital technologies, as you can imagine, building this graph will very quickly lead to a surveillance state, because the government needs to know where each of these people were, which restaurant did they go to, which wedding did they go to, which church did they go to, and so on. So the goal is, how can we solve this problem without building a surveillance state? So the idea here of SafePaths and safe places is that everybody has an app. You turn on your GPS and Bluetooth. If one person, as shown on the top, becomes infected, then they go to the hospital and they release some information about themselves in a redacted manner, anonymized and redacted manner. And we use a web tool called Safe Places to release that data. And then everybody else can download effectively this trail of the infected person and do a matching on their own phone. So as you can imagine, for everybody who's healthy, there's complete privacy, because all you're doing is downloading those infected trails. And for the infected person, they're only releasing it under HIPAA or whatever the health regulations are to the authorities. So this kind of interesting challenge, right? We seem to have either privacy or utility. So if you think about Google Maps, and we can see traffic on Google Maps because all of us willingly give away our GPS location, which is our location of our cars, to Google. And in return, Google provides this fantastic, traffic map. On the other hand, if you want to do, again, a Google map of all the infected people and see who's coming in contact with who, we just can't do that because health data is considered very precious, and we just cannot do this prediction. So the privacy becomes a challenge and we don't get enough utility. So the question for us is, can we achieve both? Can we get privacy and utility at the same time? And that's the goal of COVID SafePaths. And privacy is just a placeholder for this problem that we don't want to share information with each other. And that could be because of consent and dignity of the individual. It could be because of regulations like health regulation or legal regulation. It could be because of trade secrets. Maybe the insurance companies and the medical players and the governments don't want to share the data with each other. It can also be issue of national security because if one individual goes from one country to another country, they may not want to share all their social graph. What is this person is a nuclear scientist or a fighter jet pilot? And even if you do all of that, what's in it for the people who are healthy and they think they're never going to get infected? Why should they participate in such a system? Because in an epidemic like this, a tiny fraction of 1% of the people are going to be infected. So what do you do? So let's look at why this is the problem, right? Because we might think even GPS locations are actually very low stakes, but in reality, they can cause a lot of trouble. So Strava, that many of you use for outdoor activities, releases a heat map of all the, where people are. But because of those heat maps, which are anonymized and aggregated trails of all the outdoor activities, it ended up exposing the military bases of the US in Niger and in Syria, because only Westerners use, Strava. And in Taiwan, the Strava heat maps actually revealed the social graph of people who work in sensitive facilities like nuclear plants and so on. What about Bluetooth? Bluetooth is actually even worse, because if your phone emitting a beacon of any kind, including your earpods and other accessories, they can actually easily snooped by an app that's widespread. So imagine an app that has 500 million or 1 billion installations. that app can actually listen to all these transmissions from your Bluetooth signal and very quickly create a map of everything that's going on. So let's come back to the COVID SafePath solution. So in V1, it's very simple. All you do is download the app. It doesn't ask you for your email or phone number or name or anything like that. It simply starts logging your personal location history and anything you're listening on Bluetooth. And then you can also download some public infection data, such as cases that are appearing in your county or in your zip code and things like that. And you can see how things are going. In version 2, the expectation is that an infected person who's using the PrivateKit app, the SafePaths app, goes to the hospital, and the health professionals can release redacted data of this individual to the public. And again, the users, all the healthy users, can download and see if there's an intersection. So the data might say, infected person was at Starbucks at 2 p.m. on Tuesday. They were at the grocery store at 4 p.m. on Wednesday, and they went to a wedding at 5 p.m. on Saturday, right? And you just want to know if you're at that time at that place to get this information. And in version 3, which is not out yet, we want to reduce the burden on health officials by making this process completely automatic, using computational either hashing or cryptography, so that the data can be released without having to do all this redaction. So that's on the app side. But we also have to do something before I go on. This is how the app looks. You're welcome to download and play with it. It's still in beta mode, but it's been out on App Store for a few weeks now, right? It shows you whether there's a data match, shows if there's not a data match, and what you should do to go forward. So that's SafePaths app, but there's also Safe Places web tool, which is used by public health officials. And they would, if an infected person shows up, they would open a web tool called Safe Places, which is all open source, by the way. And they would redact information that could be identifying. So for example, they'll delete everything about your house. They might delete everything about your work, if it's a small workplace. They'll also delete if you just drove down the main street in your own car. There's no need to kind of warn people because you're in your own car. They'll delete that, and they'll keep everything else, right? If you went to Starbucks, you went to a grocery store, you went to a wedding, those things are kept with their time slots. And that information, without personally identifiable information, is made available by anonymizing, aggregating, redacting, blurring, and encrypting, and so on. And as I said, users can download this data and see if there's a match. Now, public health officials actually need much more than, let's call this encounter information, right? They also need to know, they need to be able to call and say, hey, can I check on this person? Are you over 65? What can we do for you? Are you, a mother with 2 kids? Single mother with 2 kids? You can't just, we can't just tell you to isolate or show up for a test. Let's figure out what's the solution for you. Are you somebody who cannot afford to live in a house if to quarantine because you lose your job? So how can we get food delivered to your place through agencies and so on? They also want to do symptom checks. They want to do verification of quarantines. They want to issue immunity passports. They want to provide some incentives, like how do you provide sick leave in an automatic manner? Because you're not sick, all we're telling you to self-isolate. So how do you prove that to your employer? And on the public health side, they also want to do hotspot analysis. Where is the spread? And also coordinate all kinds of at-home population, saying, hey, are you really staying at home and what can we do for you? And of course, all this kind of testing to certificate workflow. So it's a pretty complex problem. It's not just about identifying who was close to who. So as I said, this is an awesome team at MIT. We have myself and Sandy Pentland and Kent Larson and Kevin Eswald for the faculty team. But we have the leaders from WHO and Human Health Services, Brian McClendon, former head of Google Maps, Subbu Subramaniam, head of Facebook Maps, Suraj Kappa, who leads innovation at Mayo Clinic. They're all shaping how we work together. And of course, we have fantastic mentors. People like Ron Revest are in RSA, and also research mentors like Yoshio Vengio, the 3 individuals who received the ACM Turing Award for machine learning, Richard Yanda and John Halamkar from Mayo Clinic. And because of all these efforts, we also have fantastic relationship with many companies and large tech players, including EY, who are doing a lot of rollouts for us. And we have also launched a nonprofit called Path Check, which is being led by Greg Nadu, and many other organizations that are working in the space of digital solutions for the epidemic have merged with us because we are the only team that's so large, open source, and believes in open standards. So we are not about the app. We are not just about creating tools for public health. We are completely open source. We build modules. We're helping many states and many countries build solutions for themselves. So anyone can download our app, and we have teams that can help them create an app for their own country or their own state, and also building a common backbone. So any app that doesn't use our code can still be in an interoperable form. Now, one of the most common question today is, what about the so-called contact tracing from Google and Apple? Which for us is just a beautiful news, and I'll tell you why it's great news. At the same time, it doesn't solve the whole problem. First of all, it's a proximity API. It is not contact tracing. Because as I said, contact tracing is more than just telling who was close to who. Contact tracing involves being able to call the person who could be exposed and checking what you should do for them. Do they have symptoms? Do they have underlying conditions? Do they have a family or work situation that needs to be addressed? And after all of that, what should be the decision taken to help this person, right? Nevertheless, the way Google and Apple proximity API works is very nice. You know, let's say there's Alice and Bob. Alice is healthy. Bob is going to get infected. They exchange keys on their Bluetooth with their phones. And once Bob is infected, Bob will upload his keys, actually just the key for per day, to the Apple and Google server. And then Alice will download all these infected keys to see anything she received over the local channels or the local Bluetooth matches the keys that she downloaded from the server. And if it matches, then she knows she came in proximity to an infected person, right? The beauty of Bluetooth is that it's much more precise than GPS, and it doesn't have the problem of people being on different floors. You know, it's really can be very close to 6 to 20 feet, which is what we care about in this epidemic. So on one hand, the fact that these companies have opened up their APIs is great news for us, because we can embed this API and make the solution even more robust. On the other hand, it has many other issues if you used in isolation. So let me talk about that. So GPS versus Bluetooth, right? First of all, the technology for co-location or proximity should be multimodal, right? It should use telecom data, GPS, Bluetooth, and Wi-Fi waypoints, right? And the combination of the four actually allows you to do more. Some exotic versions might use motion sensor or use ultrasound and so on, but those are pretty clumsy. The problem with Bluetooth is that it's a square root of n problem, which means that in Singapore, where they have another app that's based on Bluetooth, if you have 12% of adoption, the square of 0.12 is only 1.44%. So even if 12% of the population has adoption, the likelihood of encounter between that population is very, very small, right? So that's kind of the network effect problem. GPS, on the other hand, scales very linearly, because if 12% of people are adopting it, there's likelihood that 12% of the infected sites will be available on safe places in this web tool. And everybody else can benefit, because even if they don't have a smartphone, even if they have feature phone, even if they have a landline phone, they can just see on a 7 o'clock news a map of their town saying 2 o'clock at Starbucks on Tuesday, 4 o'clock at grocery store on Wednesday, and if you're at this wedding site on Saturday. If any of those conditions are true and you have symptoms, please call us. And even if you don't have symptoms, but you're an at-risk individual, elderly, or have immunocompromised health, then please call us right now, right? So that's the benefit of GPS. Another problem with Bluetooth is that you have a lot of false positives. You know, people from a neighboring office will exchange Bluetooth keys. And false positive is alert, an Amber Alert effectively, that says there was an encounter. Then you're going to stop caring about all those alerts, very much like you ignore the Amber Alerts, right? And same thing with false negatives. You could be at a wedding where the infected person leaves their phone in their purse, let's say, and only the people who are next to the purse will get the Bluetooth tokens. But this person might have met everybody at that wedding and danced with folks and shared food and so on. So what we need to do is actually ask everybody at that wedding to self-isolate, not just the 5 or 6 people who exchanged the Bluetooth tokens for that in a particular time. The other problem with thinking about purely Bluetooth and the Google Apple API is that we need to understand the context. Whether that encounter happened at a Starbucks or at a grocery store are very different things, because maybe at the grocery store, I was very careful and I was wearing masks. But maybe at Starbucks, I was not wearing a mask. Or maybe in a situation where I shook hands or did not shake the hands. So I need to know where that encounter took place. So for me to start believing, what should I do with this information? When I get this alert that you did encounter, you did cross path with somebody who was later, diagnosed positive. And this encounter situation also doesn't allow public health to create heat maps or start predicting weather spread analysis, because that encounter could take place, without the context of the location and the event. And finally, as I said, it's not about tracing. Public health also need to figure out, quarantine procedures and health verification and immunity passports and all those things. Nevertheless, we are building a whole backbone, not just an app or open source tool. So anybody can plug into it, not just contact tracing apps, but other apps as well. And so we are not in this to kind of compete. In a classic MIT spirit, we are here to collaborate and help everyone. So finally, as I said, we want the choreography by the government. This is a public health issue. It's an issue about coordinating the economy, whether it's restarting the economy or making sure the economy keeps humming. It's about dealing with the second wave. And over time, it's about resilient society. But to do that, we need a bird's eye view into everything that's going on. And to achieve that bird's eye view, so that government and other authorities can choreograph everybody's interaction and tell us whether to leave our houses or not, when to start the schools or not, or if you did encounter somebody, creating an early warning system, all that coordination is being done by the government, but cannot be done in a big brother manner. We cannot create a surveillance state, and citizens still needs to feel that they have a sense of agency. And so we need to create private tools to coordinate between citizens and their communities. And that's what we're doing by building resilient societies. Thank you.
Well, thank you, Ramesh. And I will just reiterate that the work which you're doing and many other MIT faculty and staff and researchers are doing at this time is really commendable. And for us, sitting far away from Cambridge, it makes us really proud of the Institute and all the collaboration which is going on to make a better world. So thank you, and really appreciate all the effort going in. I'm going to switch the screen over and start displaying some of the questions which have popped in, and we'll start taking questions from there. So those of you who have joined recently, please go to the link in the chat window to post your questions. And Ramesh, if you could stop your screen share, and then I can post the questions up so folks can see it as well. Thank you. All right, so why don't we start off from this top? I think you addressed a little bit of this, but can you go, I mean, we probably have a very technical audience here as well. So can you go into like how Apple and Google are tackling it, and where does MIT fit into this from a more of a technical perspective as well?
Yeah. So let me explain how the Apple and Google scheme works one more time. So a little bit more detail. So there's a notion of a daily key. So every minute, let's say the phone of Alice and Bob, and they're exchanging their Bluetooth keys. So Bob, transmits a key that's captured by Alice. Alice emits a key that's captured by Bob, and those keys are rotating every 15 minutes. And then Bob and the keys stay with the phones. So Apple and Google never hear it. At some point, Bob gets infected, and Bob releases the daily key that can create any one of those keys that are rotating every 15 minutes to, let's say, the Apple server. And the Apple server effectively becomes a host of all the so-called infected keys, right? And they're very small, because if you have 1 million people infected all over the world, there are only 1 million keys on that server, because there's only one key, sorry, 1 million times 14, let's say, only 14 million keys on the server. So it's a pretty small file. And then every phone in the world downloads that key every day, once a day. And then when Alice gets those keys, she checks by generating all the keys from that daily key, whether any of the keys she received locally or Bluetooth channel matches with one of those keys. So it's a pretty straightforward algorithm in that sense. It's privacy preserving because Apple and Google have a hold on that server. So it's only apps that have been approved by Apple and Google can talk to this server. So in that sense, it's still Big Brother from an Apple Google point of view, but of course these are benevolent companies, so we can assume that the process is fine. Of course, if it was not a benevolent company running the server, then the apps themselves that are running on the phones could be snooped by these big companies, and they can reconstruct everybody's social graph and use it for all kinds of things. Of course, for advertising, but figuring out who's meeting who, selling products, influencing your opinion, and even could be a national security issue, right? So that would, but fortunately these companies are not, so I think we should be fine. But the problem now is there could be a third company which has, let's say, 1 billion downloads. Let's say everybody in the US has this third app. What they could do is they could release an update to their app, and for them, they're just salivating because now all these keys are being emitted, because remember, our phones usually are always silent. They never emit, a Bluetooth beacon. They only listen to paired devices, like your car or your AirPods and things like that. So anyway, a third-party app could start listening to all these signals, and if Alice is keeping the same Bluetooth ID for say 15 minutes, then user 1 can trace Alice and her GPS location for 15 minutes. When she crosses over and goes to another part of the town, a different user, but using the same app, can trace, and so on. So effectively, you can create this jigsaw puzzle that this third-party app can just reconstruct very easily, computationally. And this third-party app, for example, can reconstruct the social graph of all of the US in just a couple of days, right? So third-party app could figure out, the social graph of, say, a nuclear scientist. So it's a problem.
Okay, so does it make sense? I mean, there've been a bunch of questions around this and the algorithms, and so why don't we just go through this? The early versions seem to destroy battery life. Is there any path to improvement on this?
You're talking about SafePaths, right? The SafePaths app. So yeah, so our goal has been to have it out there, so that we can experiment and so on. But we are not right at this stage. Our strategy is to actually work with public health officials, and they are the ones who are going to push it to their own population. So in that sense, we're not a classic app company. It's not like a bunch of kids who want to build an app and see where it goes. Our strategy is to work with public health officials, and they are the ones who will promote for their own population this app. And they might release our app, or they might release a white labeled app based on our source code, but they will all talk to the same backbone. So there could be hundreds of SafePaths apps, SafePaths Brazil, SafePaths California, SafePaths Nigeria, but they'll all talk to the same base, and they'll also automatically they'll also have the Apple and Google APIs, but there are many other APIs that other companies are releasing as well. So we will create that backbone. So we wouldn't call our app as kind of consumer ready. You can download and play with it, and it'll get better and better. So we'll have a flagship app called SafePaths. which will be amazing. And you can see it in a few days. But our goal is to really build that community of apps that can still have the same framework.
So, so I have a question over here from Ron Koo. Is the location data stored on the user's phone exclusively? If so, what if the location data log is lost because the phone is lost or damaged?
Yeah, that's a very, very good question. And I think it's a trade-off we have to make. Remember, we don't ask for name or phone number or email address. There's no account as such. And I think the later versions, we could relax that notion. So for example, we could use, iCloud, or we could use, Google Cloud or things like that, so that people, if they're already using a secure storage, they can keep a backup on that. So I think that's straightforward to do for us, but that's not our primary goal. So as our partners come in, we'll start supporting all those features as time goes on.
So this one question which has come up is like, what happens after the COVID-19 contagion runs its course? What happens to the tracking technology? Will it be turned off? And how do you sort of scale it down before it gets abused?
Yeah. So first of all, there's no such thing as tracking technology, because for the healthy person, which is 99.99% of the population, your location logs and Bluetooth logs never leave your phone, right? So in that sense, the server architecture becomes very easy. It never ever leaves your phone. For the infected people, which will be a tiny fraction, they release their data only by consent, and even then after redaction, and in the next version in an encrypted form, right? And so public health authorities can decide to delete it after 14 days, or it's up to them how they want to maintain that. So in that sense, we don't have to worry about keeping a log of anybody's location data. Makes our life very easy.
So where is the contact tracing calculation performed? Is that on the cloud? Is that on the phone, or both?
Yeah, so it's decentralized. So it gets performed on the phone. But as I said, depending on the scenario, so for example, we work with the Indian app called Arogya Setu, and that uses SafePaths architecture and SafePaths privacy principles. But when they launched it, and I advised this team, when they launched it, they changed the privacy philosophy, and they use the same philosophy, which is everybody logs their location, and the data is never uploaded. But then when the infected person just does go in and gets marked, they have a policy that anybody who was close to this infected person, their information also goes to the government, and they can call all these people. As you can imagine, in many countries, the population just may not have enough technology savvy or have enough understanding of public health issues, that if they just get an alert saying you might have an encounter, they cannot do much about it, and they expect somebody to actually call them. I would say even in the US, I don't think an app telling you that you have an alert is something that people appreciate. I think they'll also appreciate somebody calling them saying, hey, we want to call you because sounds like there was an encounter, doesn't mean you're infected, but let's talk about your situation. So I think there's some trade-offs in how we create this system. Did that answer
so I'm good. Yeah, I think so. I'm going to take the privilege of being the moderator to ask a question. So there could be a large pool of asymptomatic carriers, which could also then provide this false sense of security that everything is fine. And so how do you sort of balance that with sort of putting people at risk or putting the public at health risk?
Actually, this is the whole point of somewhat automated contact tracing. So, if you're at the same location or your Bluetooth ID was captured, and you get an alert that you may not be infected, but you did have an encounter, you were at that Starbucks or you were at that wedding, it's best for them.
But if it's an asymptomatic carrier, how would that work though?
So, okay.
If I'm asymptomatic.
If it's asymptomatic and they're infecting people, there's not much you can do. But I'm saying that we can isolate asymptomatic carriers by realizing that they came in contact with somebody who's infected. So if you went to a wedding and ended up infecting, if an infected person went to a wedding and say 100 people were at the wedding, we can assume that all 100 of them should self-isolate. The way it works right now is traditional contact tracing. They call everyone and say, do you have a symptom? If you don't have a symptom, they say you're fine. But what we need to do is tell all those 100 people to self-isolate, because some of them could be infected but not showing symptoms yet, which are those asymptomatic infected. And if they stay home, then we have cut the chain of infection. So that's the strategy we can use. In fact, I would say, because we are not able to scale testing very quickly, instead of talking about COVID-19 tracing and isolating, we can just move to fever trace and isolating, which means that if you have fever, just assume for the next 2 years that is COVID-19, and just inform everybody else you came in contact with, and they should all self-isolate. And that's a good enough scheme to allow everybody to go back to work. Because I don't think people are worried about dying. They're just worried about causing a lot of inconvenience to themselves and their families and their businesses and their communities. So if you can give them an early warning system saying, there is a chance of exposure, just stay home, people won't mind staying 14 days at home. Otherwise, they can go back to work.
Cool. There've been a couple of questions around your plans of releasing the app for consumers, whether in California or other parts, using the Apple Google framework.
Absolutely. So we're working with many. We are working about 30 different jurisdictions. And we have great partners like Ernst & Young, who have deployed their whole team to work with health officials. And so we work with public health officials to release an app for them. And so our flagship app, which is SafePaths, as well as apps that are white labeled for these states, would automatically have all these APIs, not just the Google and Apple APIs, but many other APIs that we're building with ourselves or with other partners. So they will have them on day one. That's what we're doing in our open source platform. We have one of the largest GitHub repository for this, so check it out under COVID SafePaths. You should definitely contribute if you want. Or you can create issues, you can create pull requests. It has been translated in, I think, 15, 20 languages already. You can contribute to languages, or you can start doing documentation. There are many ways for you to participate and in this big open source community. We get emails from literally every part of the world every day saying, hey, how can we use it in our country? It's very easy. If you're from country X or state X, download our app, stay in the same GitHub repo, white label it if you want, and use our logo, it's up to you, and launch it, because we'll have great quality QA, great security, great privacy. We also have a think tank. I work with Sandy Pentland and Kent Larson and Kevin as well. We have papers on our MIT websites about, one of the funny ones you should read is called Apps Gone Rogue in an Epidemic. And it talks about all the crazy apps that are out there and how they have a lot of unintended consequences. And of course, SafePaths also has some unintended consequences, but we are very open about what our intentions are and where we think it could still go wrong, right?
Great. And so I was actually going to ask you, that is my last question, how we could help. So you've already answered that. So why don't we go to, I'm going to switch gears a little bit and say, if you could sort of walk through the genesis of this idea and from start to launch, what was that process like? How long did it take? It seems as if in a very short time period, you gathered a lot of really creative minds around this idea and bring in really leading thinkers from academia as well as from industry. So can you just share with us how that all that transpired?
Yeah, but I do want to answer the question on what help we need from our MIT alums as well as others who are listening in. So we of course need a lot of talented people. So right now we're working with many tech companies, actually many of them in the Bay Area, who are contributing anywhere between 1 engineer to 10 engineers, including managers and PMs, to work on this, because we're creating a whole backbone. We are effectively building another Ethernet or Ethereum or a World Wide Web consortium, effectively. So we need a lot of backbones to make this work. So we need that. So if you're if you're a company and you can, and we're talking to pretty much all the big tech companies and medium-sized companies. So, and they're all contributing engineers, the resources, either cloud credits or source code, a whole bunch of things. So we need that. We of course need money. We need to raise about $10 million to hire, enough people so that we can continue to build this base as time goes on. And it's not, the epidemic will be here, according to my colleague Kevin as well, for roughly 5 years. So, COVID-19 itself will be here for about 5 years. It's not one wave or 2 waves, it'll be with us for a very, very long time. And this is at least, let's say, a natural epidemic. But if it's an engineered epidemic, we don't even know how we're going to stand that. So we need to have this capability, the same way we have a national defense for terrorism and wars, we need a similar national defense for epidemics. And at the same time, even low stakes situation like flu and measles and other things can also benefit from this. And over time, if you want to build resilient societies, it's not just about health, it could be about other causes. It could be financial shocks or socioeconomic, social shocks, could be climate change. For all these possible disruptions, we need to build resilient societies. So we need to build that whole backbone. And that's what we're doing. In the beginning, we're going to focus, of course, on COVID-19. And so we need to raise about $10 million for the next year to do that. So please help us go to covidsafepaths.org and contribute there. And we already have very good seed funding. So we're very, very happy about that. But we need to go much further than that. So that was that question. And then what's the genesis of this? So it's funny, I was actually at Burning Man a couple of years ago. And there's a booth where there's a booth that says, talk to God. And people pick up the phone and they start talking. It turns out I was the God at Burning Man. I was sitting at the other end of the phone line and answering the calls. And what I realized is that people have a lot of frustrations and challenges in their life. And the reason why they pick up the phone and are willing to talk to God is they think there's somebody out there that has effectively a God's eye view that is omnipresent and omniscient, and that can move the right pieces and actually make actually solve the problem, right? And of course, the assumption is that this God is, impartial and honest and benevolent. I think in today's world, if you think about traffic, Google is our benevolent God, right? But we need a benevolent God in pretty much every area of our life where we could have disruption. An epidemic is a good example. So I have a research group at MIT, which works on private and distributed machine learning. And the goal of this whole group is to create, this all-knowing, impartial, honest broker for the world. So when we started seeing, so we're doing a lot of work in this space already. And when we started seeing cases from China and Korea, I was at a conference in Florida in February, and we had, the FDA and CDC just talking about something else altogether. It was nowhere on the scene. Nobody's talking about COVID-19. And I said, this is kind of crazy. These are the smartest people in the country, but nobody's talking about it. We should build a solution to make it happen. So we started assembling a team late February, and it's been an amazing journey. I think everybody jumped in. I have done this kind of things multiple times in my life now to get kind of a movement started. But this is something completely out of control, because we have some of the biggest players helping us, WHO, HHS, Ernst & Young, Mayo Clinic are official partners in many ways. And then we have about 80 people who are part of the core team that meets every day at 11 a.m. If you want to join one of these leadership roles, please email me. And then we have about 200 to 300 people in the ecosystem who are either programming or translating or writing code or writing documents or calling up public health officials and all those things. So it's kind of amazing that in about 5-6 weeks, we have come this far.
Yeah, I was going to say, like, end of February was just like 5-6 weeks ago. So you now are live in how many countries? So
our goal is to we are in discussions with about 30 different jurisdictions.
Mm-hmm.
And so they have to kind of go and launch our solution for their jurisdiction, right? That's our goal, because the challenge, so, public health is not like starting, an app, or even not even starting an Uber, which is still a more complex problem than launching an app. Public health is actually a much more complex topic, because the notion of privacy is different than, say, privacy on, cryptocurrency, right? Because at the end of the day, the individual still has to go to the hospital.
Mm-hmm.
So in that sense, privacy is very different. So you really care about the privacy of the healthy people, but the privacy of the infected person is very different, because they have to go get care, right? So we have to balance that. And that's why public health is a very local topic. It has a lot of cultural issues. It has a lot of kind of, nuances of how these things work. So I can't imagine kind of a global solution that will work for this, because proximity is a tiny piece of the puzzle. Contact tracing gets you somewhere. But what we really have to do is solve this public health issue. So in that sense, we have to really work with these public health officials.
Mm-hmm. So right now, when SafePaths is available on the App Store, but you really, for it to work, you need to, for each jurisdiction or each county or each state, you need to have the appropriate public health officials signed in.
Right.
Right. And then same thing, I guess, globally as well, right?
That's right. Yeah. It's going to be,
downloading the app is not sufficient.
Yes. Having a single app is not going to work. So it has to be in local language. It has to link to local resources and so on. And you could imagine writing, as Uber works in every country with a single app, you could imagine writing this 1 mega app that morphs in different ways. But in reality, these are just different, completely different versions of them.
Right.
But as long as they have a common backbone, so if you go from Brazil to Mexico to the US, you might use 3 different apps, or you might continue to use your Brazilian app, but it doesn't really matter to us because we're still on the same backbone.
Right. So I'm going to bring up some questions from the windows here. So one of the questions is like, what kind of policy changes need to be made to current pandemic responses to promote resilient societies?
Oh, that's a great question. That's a really great question, because we might be the richest and powerful country, but we have the worst coordination at a kind of, on a protocol level, policy level. So as I said, the way every state works in the US is just mind-numbingly different. It's just mind-blowing how different it is. So you just cannot deploy a digital solution if all these workflows are so different in every state. So it's going to be a big challenge. But the very first thing we need to do is say, wash your hands, keep social distance, and please, please, please start logging your location. If everybody just did that, it'll kind of help us, restart the economy. Because, the moment somebody gets infected, we can just backtrace and help everybody else. The second policy change we need to do is create an incentive model for any infected person in a verifiable way, let everybody else know, right? So, you can imagine being infected almost as a lottery, a kind of a negative lottery. Say, the government should just give you, $1 million, to kind of get going, because we lost $1 trillion anyway, right? On this thing. If you had just given $1 million to each person who was infected and just gave them all the resources and just stay home, we could solve this problem. Maybe $1 million is a lot, but even if you gave them $2,000 or $1,000 per week, that they cannot work, because whatever concerns they had that they should be out there infecting everybody else, that would have helped, right? So creating that incentive model, so for every infected person to become part of the digital system right away, would be very good. And number 3 is that I know a lot of people think it's all about testing, but that's a fallacy, because we are not going to test, 300 million people in this country. So we need to have a much easier ramp to a testing solution. And that could be a symptom checker, that could be, coughing, sneezing, fever, and so on. So if we can create a privacy preserving system where people can contribute their current symptoms in a verifiable way, and those of you think about blockchain, those of you think about, certificates and so on, there are ways to do this. If you go and buy, aspirin or something, that should be an indicator. So you must spend $5 to verify that you actually have fever, for example. So you can create very simple checks into the system to do that. So I think focusing on testing and masks and ventilators is an unnecessary distraction, when in reality we can create much simpler on-ramps to deal with this. So I think there are three things. Ask people to log, incentivize infected people to be part of the digital system, and create a solution that actually is it's a good on-ramp as opposed to focusing on testing.
Got it. Thanks. And I'm going to ask a follow-up question, which I put up earlier. Would it make sense to overlay additional data sets like credit card usage data to then see what patterns are, like people buying aspirin to treat, fevers and things like that? Or is that too big brother and we should stay away from that?
So the whole research I do in my group in private and distributed machine learning has that angle, right? Which is, how can we create solutions that so far have assumed that we must centralize the data, but can we do that, without sharing raw data, right? We can share wisdom from the data, but we don't share the data. Some of you know about federated learning. Our group at MIT has another technique called split learning, SPLIT. And in our opinion, split learning is much more suited for the problems we're talking about here. It can work on edge devices very powerfully. And so, yeah, absolutely. Telecom data, credit card data, your loyalty cards, your drug purchases, all those things should be part of creating this bird's eye view, as I talked about from Burning Man.
Mm-hmm. Cool. So Ramesh, I think we're coming towards the end of our talk here. So what are some sort of parting thoughts and pearls of wisdom? And I'd like to end this on a more positive, not a doom and gloom situation, but what's the silver lining in all of this?
Yeah, I think the silver lining is that, any crisis is, kind of makes us rethink where we are. And I think this crisis is going to bring such a big change in the way we deliver health. Overnight, hospitals and clinics have moved to telehealth. Overnight, the rules for HIPAA have changed. Literally 2 organizations across the state boundary couldn't talk to each other. Those rules have disappeared. And some of them there for good reasons. Most of them were there because of legacy reasons. Digital solutions are becoming very common. Privacy is an important factor, but privacy was also a hindrance because of, again, regulations or trade secrets or national security. But now we have solutions that can have utility and privacy at the same time. So I think we're going to come out of this and look at public health and personal health in a completely new way. And we're going to start questioning everything. It's probably similar changes will happen in how we work as well. I think instead of working 4 days in the office and 1 day home, I think it's going to be the other way around. People say, hey, actually we did fine. So it's going to be 1 day in the office, 4 days at home, and spend enough time with their family and loved ones, as opposed to getting stuck on 101, right?
Right.
So I think we're going to see a lot of positive changes in and I think just staying home 4 days is going to change, our contribution to climate change is going to improve on that. So I think there are a lot of interesting things that will come out of it, but I'm very excited about the digital health aspect of it. If you're an entrepreneur, if you're an investor, if you're an innovator, now's the time to think about a completely new, digital health, innovation. Because I have done a lot of health tech startups, and I know they're a pain to run and to scale. But now's the time to actually do it. So that's maybe a positive outcome that will actually get health not just in a more convenient way, but will reach the underserved, and the $5,000-$10,000 each of us spend on health might come down by a factor of 2 or 3 in the next few years.
Well, that brings us towards the end of our talk. So thank you so much, Ramesh. Really appreciate it. And like you, I'm really optimistic about the next normal, where the way we live, the way we work, the way we get our health is all going to change, and hopefully for the positive. And that's a good segue into our next topic, which is going to start off in about 4 minutes, which is investing in healthcare opportunities, and what are some of the challenges and opportunities there. So thank you, Ramesh, and the audience, please stay on. Afsana and and the rest of the team are going to be joining in shortly for the next session. So,
thank you.
All right, over to you, Afsana.
Great. Hi, Shuja. That was an excellent discussion. Thank you. I guess we'll just wait a little bit for our moderator and panelists and attendees for the next event. Hi, Sebastian, I see that you're on. How are you?
I am doing well. How about yourself?
Excellent. I'm well. Thank you. Thank you. I'm glad you are on. I'm trying to see if I want to change my background. Haven't done a lot of that before. So let's see, choose virtual background.
Hey, Alsana. I'm going to share my screen real quick.
Okay, that's cool. Hi, Serena.
Hi, that way people can see. Oops.
These virtual backgrounds are weird because they edit the
I will be back.
Okay. I'll just stick with my wall. So, how about you, Sebastian? I think like for all men, the beard is like the thing. Do you normally have the beard or do you normally not have the beard?
No, I don't normally have the beard.
Okay,
I started during San Francisco's